Hi guys, welcome to my state-of-the-art laboratory. Today we're going to be looking at the law of conservation of mass. We've been talking about that in our lessons, and we've been talking about Lavoisier, who came up with the law of the conservation of mass, which suggests that matter cannot be created or destroyed. What that means is when we have a reaction, although the chemicals may change their appearance, the mass, the total weight of the chemical reaction doesn't change. So that's what we're going to be looking at today. We're going to be looking at acetic acid plus sodium bicarbonate, and the chemical reaction will take place to produce sodium acetate with water and CO2, carbon dioxide. You'll see I don't have my lab coat on, but I've got a shirt that will allow me to protect my skin from anything that happens. I've got my gloves on as well and my safety glasses. I'm using glassware, so even though the chemicals I'm using today aren't that dangerous, getting things in your eyes like glass or even the vinegar would hurt. So it's always good practice to make sure you have all your appropriate safety gear on. Okay, so acetic acid doesn't sound fantastic. All that is vinegar. And the sodium bicarbonate is bicarbonate of soda. So you may have some of these items in your house. You're more than welcome to try this experiment at home as well. What I do have that you might not have access to is a balance. Now, balance is a really precise measurement, so we can put things on there like a scale, and it gives me decimal places. I'm going to be rounding up today just to make it a bit easier. I've got a calculator to make sure I don't do any dodgy maths. I've got a couple of balloons and I've got my beakers. So let's just do the experiment. What you should have in your workbook, and if you don't have it, you can pause the video here, is this table. What we're going to be doing is measuring the weight of the reaction before and then afterwards. So we're basically measuring the reactants, then we'll measure the products. And hopefully what we'll find is there's no difference, or there might be a slight difference in the weight, but there shouldn't be any difference even though the substances look entirely different. So what do we need to do first? Well, the first thing we have to do is measure the test tube and the beaker. So I've got a test tube here, my beaker here. I've tiered my balance so it's at 0. And I'll put this on, and the test tube in the beaker weighs 129.9. I'm just going to round it up to 130. Okay, so we're at 130 grams. Now, what do we need to do? It says test tube plus beaker plus vinegar. So now I need to add some vinegar into the test tube here, which I'll do. Plenty. Okay, now all I need to do is measure that. So if I put that back on the scale, 136.4. So we'll just call it 136 at the moment. Okay, now what we need to do is measure the weight of the vinegar on its own. So to get the weight of the vinegar on its own, we already know the weight of the test tube and the beaker, so we just take this total weight away from that, and that tells me how much vinegar I have. So 136 minus 130 equals 6 grams of vinegar. Perfect. That's the first part of the experiment done. Now, if I flip this over, we have the second half, the bicarbonate of soda. So what we're going to do is put the bicarbonate of soda into these balloons. So ideally you want to use water balloons, but we couldn't find any of those, so I've used these normal balloons. They work as well, so they do work for the experiment, but just a little bit tougher to get onto the test tube in a second, but it's okay. So what we need to do is, I'll tear that again, put the balloon on here. So the empty balloon weighs 1.79, so I'm just going to call that 2 grams. Now I'm going to put some bicarbonate of soda in there. Now that's quite tricky to do with this kind of balloon, so I'll try not to burst the balloon or rip the balloon. So if I open it up like that, and all the way down to the base, so I can get in there, perfect. And what I'm going to do is I've got my bicarbonate of soda, I'm just going to pour that into the balloon as best I can. Perfect. Okay, so there's plenty of bicarbonate of soda in there now. Now what I need to do is measure or weigh this again now. The balloon has bicarbonate. and 4.6 for the bicarb. 4.6 for the bicarbonate soda. Perfect. So now I'm going to get the weight of the bicarb, so D minus C. So 4.6 minus 2, 2.6 grams of bicarbonate. Awesome. Now what I'm going to do is take the total mass. So I'm going to add the weight of the vinegar, the beaker and the test tube, and the weight of the balloon and the bicarbonate soda all together. And that gives me the total weight of all of the items and my reactants. Okay, so the total weight, so we've got 4.6 here. I'll just write that here. And what did we have for the total weight? The total weight was 136. So 136 plus 4.6 equals 140.6. 140.6 grams. So when we do the chemical reaction, what we should find is hopefully within, because I've done a bit of rounding, but within about 140.6 grams is the weight. All of this should weigh again once we do the experiment. So let's do that now. What we're going to do is you take your balloon and we want to stretch it a little bit to get it over the test tube and get a nice kind of tight fit over the test tube. This is probably the fiddliest part, but once you do this, make sure it's on and then you hold the balloon on tight. So we don't want any of the bicarbonate to drop in at the moment because that would start the reaction. Okay, so I've got the balloon on there. I'm going to make sure that goes on tight without getting any of the bicarb in. Okay, so you can see the balloon with the bicarbonate soda is on here, this side, the vinegar's on this side. The chemical reaction hasn't occurred yet, so we still have the acetate and the bicarbonate soda. And then when I start to tip the bicarbonate soda in, you'll see there's a reaction, okay? The balloon's starting to get bigger. That's the carbon dioxide that's being released. And what a lot of people do here is they will not hold on to the balloon. So you're going to hold on to the balloon as much as possible. You can see the reaction occurring here. Once the reaction subsides, you still want to hold on to the balloon because you've got all the carbon dioxide. The balloon's trying to pop off at the moment. Once that subsides, then we'll reweigh everything together. So we've got everything we need here. We'll put it back in the beaker. So let's just make sure that that balloon's on tight. Still going, there's still a little bit of bicarb dropping in. You don't want to let go. Okay, so there's a little bit of vinegar dripping down the side, but that's okay. What I'll do now is carefully place that in here. Back on the balance. 141. So it is within 0.4 of a gram. I'm pretty happy with that. I rounded up a little bit. So 140 and 141 before and after the experiment. If we rounded this up to 141, then it's exactly the same. So that's fantastic. So Lavoisier was correct, the law of conservation of mass, even though the chemical reactants changed into something completely different in the products, the weight of the experiment is still the same. And we managed to measure that by capturing the gas that was released. If we lost all that CO2 and hadn't captured it, it would look like the experiment lost weight. But because we've kept it enclosed, then we've managed to predict, or not predict, but demonstrate that the weight doesn't change. Thank you guys.